name is Piotr Białczak. I work as a senior researcher at CERT Polska, and also I'm PhD student at Warsaw University of Technology. You can reach me by email or by Twitter. So I've always wanted to begin presentation with cat picture, and today I'm doing it. It illustrates the mechanism which I think applies to work of blue teamers when they try to hunt malware using some blacklists or some information about infrastructure, malware infrastructure. So I think a lot of people wish to be that identification via this blacklist IP addresses domains was useful and effective, but I think it's not. It's not. IPs, domains constantly change, and malware developers introduce some dedicated mechanism for evasion, like DGA, fast flags, all these things. And and when these things are maybe effective when we know the threats, but when we encounter an unknown threat, these lists are useless. So what should be, what could we do if we have maybe some mechanism to identify something constant in malware behavior, which also could provide some distinguishability between malware families? I would say that it's malware fingerprinting and malware fingerprinting using network traffic, which I will talk today about. With fingerprinters, tool providing fingerprinting, we can identify threats and because they use some rarely changed elements, and we don't use the IP addresses, but only those things which are like constant in all the traffic, all the messages. Fingerprinters make the fingerprints produced unique, or they should, which can give us a way to identify in some sort malware families. But also the fingerprinters can provide good generalization. That means that if we have, for example, 100 requests, a good fingerprinter can provide only 10 fingerprints or even one fingerprint for all this traffic, when it's the same. Also, fingerprinting provides or should provide an easy way to share the fingerprints, and thus sharing the intelligence with the community, for example. I think there are two different notions of fingerprinting, malware fingerprinting. One is, I would say, is direct identification of malware families. These systems, these tools, directly provide name of the malware. And I would say these are more like multi-class malware detectors, and more than the second group, which are more generic. I will call them like generic feature extractors, because they provide representation of some features from the network traffic, from the messages. And these features do not, or these fingerprints do not give malware family. However, we can label it later. In this presentation, I will focus on the second group. So let's begin with traffic fingerprints. Majority of tools extract some payload fields from some headers. Here we can see IPv4 header or pseudo header with a lot of different fields. However, the tool should choose only those fields which are, like I said before, rarely changed, and also which are hard to change. Because if those change too much, then or they're easy to change, then they can be evaded. The fingerprinters present the results, present the features, usually into two forms, like full, presenting all the features, and concise, like hash or something like that. So some examples of usage. Firstly, you can use the fingerprinter to group activities. For example, we have, like I said before, 100 HTTP requests, and you want to know are there similar or different. It can provide identification of malware. For example, you have one fingerprint which is distinct, and you can use it as a hash to search for other messages in this format. It can be it is similar to like VirusTotal. Fingerprinters can also provide identification of different operations single malware family. For example, if we want to identify which request is, for example, for CNC and which is for information about IP or connectivity check, fingerprinters can provide that info. Also, if families are, for example, have one ascendant, then you can correlate some similar behaviors and can provide some information that these two families are somewhat similar. Now I'll present some popular tools. We will begin with Geoffrey. I think it's very popular. It provides means for fingerprinting TLS, both client and servers. It uses decimal values of some chosen fields of client hello message. These are version of TLS, the cipher suits used, list of extensions, elliptic curves and elliptic curves point formats. All these things are concatenated, and this is the full version of the fingerprint. However, it's rather long, so we can use a shorter form, which is hashed with MD5. This tool is extensively supported. Different systems like MISP, like Moloch, monitoring with Suricata, with Zig, all the things. Yeah, it's available here. The source for GitHub. The second tool, AJ-SSH. The name tells all. It fingerprints SSH, clients, servers. As before, it extracts some fields from the one of the first messages when the SSH connection is negotiated. Decimal values of fields like public algorithms or encryption algorithms, MAC algorithms, and compression, all these things are concatenated and then hashed to provide a shorter form. Also available at GitHub, open sourced, so you can check it. I think that this is also a great tool, Fingerprint all the things. It supports both previous tools, Jeffrey HSH, but also it can fingerprint remote desktop protocol by using RDFP fingerprinter, but also GQuick and HTTP header fingerprinting. I will talk about this later. It can analyze live network, pick up files via PyShark. Yeah, all these things available here in the GitHub. So maybe some other great tools, like it's a classic tool, POV in the version 3. It supports HTTP fingerprinting. Cisco Mercury. A lot of protocols supported. And identification framework, which is called RECOG by Rapid7. It gives information about not only about protocols, but it use protocol fingerprinting, but also services, operating system, all these things. So now something more complex that tools presented before, SMTP fingerprinting. SMTP used by to send emails, to exchange emails. This method, it's called SMTP dialects because it checks the implementation of SMTP, how the client talks with the server. It looks which messages are exchanged, their case, also checks the SMTP extension, IMF fields, all these things. It can be used to detect spam bots. You can see more about this. I think this is one of the first papers about this, academic paper, however, I think very promising. Also, my colleagues in the Season project worked on this. And yes, here is a screen from the Season blog, and two different bots, Thunderbird and some spam bot. We can see some differences with exchanged messages. Thunderbird is hello and bot hello. Here is a IP address, and the bot uses a domain name. And there is a difference in mail in the mail from message. It's written in some other case. Also, there is a space after it. There is no white space here in the Thunderbird. The same applies to the second message, recipient 2. So, and at last, the quit information, the bot does not send it. So you can see the difference. However, there is no open source tool for SMTP fingerprinting. So maybe someone wants to check it and check these papers and write something in the free time. So I will now try to provide some demo. Oh, it already started. So okay, I've imported I should see security on. Okay, so I've imported network traffic pickup files from malware traffic analysis.com or .net. You know the site, and the traffic comes from the posts from 2020, and I've imported them with SO import pickup tool from Security Onion. Okay, I will like play the film. So I go to this keyword to check all the Suricata alerts. Yeah, and firstly, I've checked the time, because I like a whole year as a time reference, because the pickups are from different time, from whole year. Okay, so nextly, we can see some different alerts, and because there is a lot of malware, this traffic is almost all malware. However, some pickups have some traffic from Windows background. So we can check the traffic, and here we can see too fast. Here we can see that there is some CNC server of Dridex or Tribot, we don't know yet, and there are some alerts for it, and we will check the IP addresses. For example, here is some address from Russia, and yeah, we will now click it, and we will go to the Kibana. Yeah, Kibana. Okay, so Kibana is loading. We have this default dashboard with information about the IP address. However, we would like to use it as a filter. Firstly, yeah, I forgot to make time reference of 1 year, last year. Okay, so making a filter with IP's keyword, and I've pasted the IP address, save the filter. Okay, so now we are in the default dashboard, the main dashboard, and we want to go to some different dashboards, but we want to save this IP. So I have pinned it, and now I will go to SSL, and yeah, I think, yeah, there we can see some counts, how many times it was observed. So I've added here, it's not default, however, I've added two additional dashboards about Zig, Joffrey, and because it comes from Zig, and Joffrey S for server. And now I will try to pivot some from this. Yeah, here I wanted to filter the traffic. There was some problem, however. Okay, so yeah, I have inputted the keyword, Joffrey keyword by hand. This is the fingerprint for the client who connected to this CNC server, which was malicious, at least by Suricata. So now I've unpinned the IP, and it showed that there was 51 messages from with this fingerprint, and yeah, I think it's a lot. And there is also some other Geoffrey keys. Here are some information about IP addresses of the clients using it. So we can say that these IP addresses can provide some information that they are malicious. Okay, so next thing. Sorry, it's the film. Now I will. The filter is empty. I have refreshed for the whole year to check information about all the TLS connections, and then we have a lot of this Geoffrey keywords, a lot of fingerprints, so maybe a lot of clients, and so I have we can download it like a CSV file, and we go to terminal. Let's see how does it look. So we have a fingerprint and the count. So we have to make it a little more prettier. Meanwhile, we go to the abuse CH Geoffrey fingerprints blacklist. I have previously downloaded it, and yeah, we can cut the information about the fingerprints from the zig, from the Kibana and the zig, and then check whether any of these fingerprints is on the blacklist of abuse CH. So yeah, preparing the data. I have the data. We can write all the information to the scene Geoffrey .txt file, and then let's see how does look the blacklist. Geoffrey information about mother family. That's all we need. So okay, we use advanced tool called grab. We will grab using all these fingerprints from Kibana to check whether any of them is on the abuse CH list. So yeah, we have found. Sorry, I cannot, but it's like here, marked with red, is Dridex. So we found Dridex. Then we can pivot all the things more. Okay, let me know if you see another desktop. Okay, great. Thanks all. So okay, the next one, because time is running out. So let's play. Now I will give you information about the FAT. How does it work? Some demo. So previously I have installed it, and yeah, FAT. As you remember, fingerprint all the things, and we will use the HTTP fingerprinting feature. So firstly, I've downloaded from malware traffic analysis the TrickBot pickup file, and we will filter out only the HTTP requests. So there is like 9 of them, and there are some different ones. This, I think, this one is like very identifiable for the TrickBot. If you ever see the traffic, because the name of the computer. So there are some different requests. There is a post request, which I talked before. Here, this free from what I remember, these three requests are used to download additional TrickBot DLL. And okay, so let's see what FAT can tell about this. Yeah, we take the pickup file name and okay, problem with the argument. However, it's like -R to read the pickup file, -P to print to the command line, and HTTP for fingerprint. So there is a lot of data, and however, you have source IP, destination IP, the protocol, fingerprint, and user agent. And however, there is information about the server side, but we'd like to filter only for the client. So we will get the info. However, it still is a lot of data. So here we cut only the destination IP with information about destination port. Okay, so here we can see there is one fingerprint is in like 1 to 3 messages. Also, there are 2 other fingerprints which are the same. Also, the same are the user agents, and I think FAT gives a good information about different requests of this malware. Like the one I showed, the fingerprint showed, was for the post request. Another fingerprint was for this post request, which is kind different. Yeah, it's like here. This post request is on other port, but also it uploads some other information than the other requests. So yeah, I think it's a good tool. So now we will go to another problem. We have emoted pickup, emoted TrickBot, and unknown pickup for some unknown malware. So we will check the traffic. Oh, there is some traffic for HTTP, HTTPS. Okay, so we put it in the pickup file in the FAT and sort for unique values of fingerprint and user agent to provide unique information about all the requests in the known pickup with the emoted. Then we will do the same thing. Okay, so now we save it as a emoted fingerprint txt file. Okay, then we do the same for the unknown pickup. We get some information and let's see what's in there. So there is some hashes, so some user agents, but let's see whether these two intersect. So with that mechanism, we can tell whether those fingerprints from emoted are seen in the unknown file. If yes, then we can say with some probability that in the unknown pickup has also emoted traffic. Let's see. Yes, using grabbing through the emoted from the known, and yeah, we have some free fingerprints with the same hash and user agent. So yeah, we can tell that the one file is the one file is the second file. It could be emoted. Now, two other malwares: BetaBot and Copter. Firstly, we will look at the Copter. There is hash beginning with 0, A, 0F, etc. Then we will check the BetaBot. All this has to show that there is also the same value for both malware families. So yeah, we have a collision here because both malware has similar requests, the similar headers. However, they are different by URL. Okay, so let's get back to. Sorry. Okay. Let's get back to presentation. The problems which we can see here is that there are in some current. This is not only from this observation, but from some of my research. Current HTTP fingerprinters have a lot of collision between families, also between malware and benign software. And currently, the analysis of URL and payload is limited in them. So yeah, I've created hfinger, which looks in the URL, like these features: length, number of directories, file extension, header structure, like request method, protocol version, order of the headers, popular headers and values. I think most of these features for the header structure are already known. And also the payload, the length of the payload, entropy, and presence of some non-ASCII characters to check the information about the payloads by the malware. So here we have a post request, which is a dummy post request with dummy data, but it provides a fingerprint with information. This is an actual fingerprint from the hfinger. It provides information about the length of the URL. It's a base 10 logarithm of the length. Also the extension of the file requested. There is no extension here, so it's empty. And number of variables in the URL. Here is only one, so yeah, it's here. Then the structure, name of the request method, version of the protocol, and then list of there is a list of headers, some popular headers with values encoded here. And lastly, payload features. It's the length of the payload of this part. As before, it's a base 10 logarithm of the length. So yeah, it's you can make as before MD5 hash from it. However, the main thing we would like to achieve with it is to give some interpretation for analysts to look into the request and check what's there by hand. Yeah, there is encoding. Some popular headers are analyzed. The values are encoded. For example, application JSON is encoded like AP.js. However, you can provide your own encoding. I don't know, even with emoji or some smiley faces. It's all for you. The hfinger have different report modes. I've presented before. There is a lot of different features which are used by Hfinger. However, if you take a lot of features, there is a lot of fingerprints given from the tool. It's the generalization. It's not very well done. So you have to make this optimization, like between uniqueness of the fingerprint and the number of fingerprints produced by the tool. So you can choose the report mode depending on your level. The default mode tries to optimize both this uniqueness and generalization. There is a more informative mode where you can have more features presented to you, but it makes also slightly more fingerprints, and all the features mode, full information. However, it's full information. The fingerprint is the most unique. However, there is also a lot of fingerprints than in the other modes. So more info. I think it's already published at CERT Polska's GitHub. You can find it there. Please know that it's a working prototype stage. I think there will be some changes. I wish to. The tool is written in Python, uses C# for pickup parsing and HTTP assembly, and comments, issues, PRs are all welcomed. You can write to me by email, or make issues on the GitHub. So maybe some demo. Let's check it. You should see. Okay, so there is a problem. I forgot to resize the size of the icons, but okay, so maybe you can see anything. There is a long string. It's not beauty. It's not so beautiful as you would like to. So we put it into the queue. Maybe. Okay, so here I resize it and I will talk about it. So I've put one of the collision files, the copter pickup, which was the FAT gave collisions. So when we put it from the JQ, you can see some information about, like before, length of the URL, but also the headers, and then we will call the beta bot, and we can see that even that the part about the request version and the headers is the same. However, there is difference in the part of about the URL. Here's the length of the URL, requested file, number of variables. So here is a different difference between those two fingerprints. So lastly, Valak. We will analyze it with Hfinger. Firstly, there is a lot of we filter out in T# the requests. There is a lot of different requests. Here is some cap file. Here are some ASPX requests. One is on go.aspx, other on RPC. There is a lot of dissimilar requests, but also there is some. Oh, maybe I will get before. Yeah, here you can see some background traffic from Windows. It's not. I think it's Windows update. So mixed traffic. And okay, now I will show it. Some different requests. Here is the request from the Windows update. It's Windows update. However, funny user agent, crypto API. Okay, so we check the file, and it produced a lot of different requests. However, we can see that there is the fingerprints are pretty the same. So nextly, we can check there is like five different fingerprints, and with these fingerprints we can both identify this shorter request, but also between these two requests, which are two different resources. Let's see whether okay. So that's all. So back to the presentation. Okay. Okay, I'm late. So quick conclusion. Fingerprints are helpful in hunting malwares. I think I showed you that, but like malware developers are also working, and the fingerprinters are good until the new mechanism of malware start to evade these fingerprints and these tools. There is all fingerprints, including H-finger. There is a problem of this generalization versus collisions. If you make the fingerprinter more to give more unique fingerprints, then you have a lot of fingerprints, so you cannot generalize in a good manner about the requests sent by the malware. Some popular tools are already covered protocols. However, there are some tools which can also be created, so call for action. And please give a try to each finger. It was part of the work was sponsored by European Union. Thank you. And that's all.